Welcome to lesson 4.5, area of a circle. So this lesson will focus on developing and using a formula to find the area of a circle. So in the previous lessons, we've learned about finding the area of rectangles, of parallelograms, and of triangles. And so this is the last lesson within this unit where we'll be developing formulas and using formulas to find areas, or to find the area of a different shape. So the area of a circle, I'm going to give you the formula, and then we're going to kind of look at the how and the why aspect of it. 'Cause it's one thing to know what the formula is, but it's kind of the other piece of the puzzle is to know how we got it, and not just to be able to use it, but to understand where those numbers came from and what they mean. So the area of a circle, I'm just going to write it in blue. So the formula that you'll need to know for this one is the area of a circle is equal to pi multiplied by the radius squared. So this is the big formula that we're going to have to keep in mind and that we'll be using within this lesson. But we're going to take one step back before we do some examples and just look at how we got this formula and how we developed it in the first place. So the first thing that we're going to look at when thinking about the how and the why did we develop that area for a circle is I'm on page 149 in our textbook, so you can follow along if you'd like. Otherwise, just listen along on here. So the first thing we're going to do is we're going to look at a circle. So I have a circle here, and I've just taken the snippet from page 149. And suppose we cut that circle into congruent sectors. And remember, the word congruent just means equal. So we cut our circle into several equal sectors. And the sectors are rearranged in such a way that they create a different shape. So we haven't done anything to this circle besides cut it into equal sections and rearrange those sections to make a different shape. And the more congruent sectors that you cut, or the closer together that these lines are, the more that this shape becomes to look like a parallelogram. So can you guys see how this circle, after we cut it into a whole bunch of bits and rearranged it, how this shape looks like a parallelogram? So essentially we have two parallel lines on the on the top and bottom, and then our sides are also parallel lines. Do you see that? So you should be thinking to yourself that that does look somewhat like a parallelogram. And the important thing to keep in mind is just the more sectors we have, or the greater number of sectors, the more that our shape will look like a rectangle. If we cut this into fewer pieces and rearranged it, it might not look exactly like a rectangle, but the smaller that these pieces get, the more that this shape looks like a rectangle. So now let's start thinking about how we developed that formula of area equals pi r squared. So we're going to kind of focus on this shape that looks like our parallelogram over here. So when I look at this shape, I see the top, the sum of the two longer sides. And when I say longer sides, I'm referring to this side and this side. So if we look at where those bits were rearranged from, those bits on the longer side of our parallelogram were rearranged from the outside. Do you guys see that? So all of these lines are the outside edges of our circle. And what do we know? What is this called about the outside edge of our circle? We know that that's our circumference. And because our circumference is essentially split into two, because we've rearranged it so we have two sides now, each of these sides of our parallelogram is our circumference divided by 2. Our circumference divided by 2. In other words, it's half of our circle. Half of the length of the outside of our circle, sorry. And this is where it's going to get a little tricky, so just bear with me. And I know it's a lot of numbers and letters going to be flying at you, but it's just trying to get us to understand how we came up with this formula. So we have the length of our parallelogram we know is half of our circumference, or our circumference divided by 2. But in previous lessons, we've learned that our circumference, I'm just going to write it over here, is equal to 2 pi r. So I think 2 lessons back we learned that formula. for solving the circumference of a circle. So if I replace this equivalent with my circumference, it then looks something, the side length looks something like 2 pi r, because we know that's equal to the circumference, so we're not changing anything, divided by 2. And I know I can just, 2 divided by 2 is 1, so essentially that equals 1. So what these side lengths now become is pi times r and pi times r. They're both the same thing. So we're just replacing this c divided by 2 with a new number. Now when we look at the side length of our parallelogram, what does this length represent? So if I look at this one little slice here, what does this slice, where is it taken from? Our pi, or sorry, our circle? I'm just used to calling them pi. If it's one circle, we know that from this point to this point is from here to here on our circle. And what is that length called? From the center point out to one edge? We know that that's called our radius. So the side length of our parallelogram is our radius, or is the length of our radius. So now we've labeled all 4 sides of what is our reconstructed circle or our parallelogram. So we have our top and bottom. Whoa, sorry, I'm not sure why that moved. So we have our top and bottom is pi multiplied by r, and our side lengths are the length of our radius. So we know what is the area, and again, bear with me, I know this is kind of confusing. If you find it easier to read through, just walk through page 149, 150 with me. So what do we know about the area of a parallelogram or of a rectangle? We know that the area of a parallelogram or a rectangle is base multiplied by the height. And so now that we've kind of reconstructed this circle, we now have side lengths for our base and our height. So let's just plug those in. So the area is our base number, which is pi multiplied by r, multiplied by our height, which is r. So there you go. Now we're starting to look at this formula that's developing for area of a circle. And essentially we haven't done anything. We've just reconstructed our circle in such a way to make it look like a parallelogram. We've figured out what those side lengths are, and now we're just kind of plugging numbers back into the formula. But we can combine what we have here, because I see we have 2 r's. R times r, what is that, or how can that be rewritten? R times r is also equal to r squared, because we know that any number squared is just multiplied by itself. So I see that we have an r multiplied by an r here, so I can combine that to make an r squared. So if I rewrite my formula now, we have our area equals pi multiplied by r squared. And if you recall, that is the formula for the area of a circle. So I'm never going to ask you to really recreate that or show on a test or a quiz all the steps and how you develop the area of a circle, but it is just good knowledge to know, and it does help with that why piece. It's one thing just to be able to plug numbers into a formula and solve an equation, but it's another thing to understand how you got that formula and how it was developed and understand where it came from. So before I send you off to do some practice questions, let's just go through one example together. So I'm going to draw a circle, and I'm going to give my circle a radius of 2 centimeters. And my question asks me to find the area of this circle. So we know that we just went through and developed the formula for area of a circle. So we know area of a circle equals pi multiplied by your radius squared. So I'm just going to write that in the top corner so I remember that. And again, just like we've always done in the past, you're just going to take the numbers you know and plug it into the formula to solve for your missing number. So I'm going to do just that. So I don't know what my area is because we're solving for that. I know that pi is also equivalent to 3.14 if you don't have a pi button on your calculator, multiplied by my radius, so I'm not going to put an r, because I know what my radius is. I know that my radius is 2 squared. So now I'm just going to go ahead and solve this. Area equals pi multiplied 2 squared, in other words, is 2 multiplied by 2. Again, it's always when a number is squared, it's multiplied by itself. It's not multiplied by 2, so just keep that in mind. So 2 times 2 is 4. And then if I multiply 3.14 by 4, I get 12.56. And we always need to remember our units. And because it's area, we know that our answer is squared. So the area for this circle is 12.56 centimeters squared. Let's do one more example together. So I'm going to draw another circle. And I'm going to give my circle a diameter of, let's say, 12 centimeters. And I'm asked to find the area of this circle. So I know that my formula for area of a circle is pi r squared. And so I just need to plug the numbers that I know into this. So I'm solving for area. Pi multiplied by my radius squared. So if I know that my diameter is 12, I know that my radius is half of that, so my radius is 6 squared. Area equals pi multiplied by, and again, 6 squared equals 6 times 6. Not 6 times 2, 6 times 6. So 6 times 6 is 36. And then my last step is to multiply 36 times pi, which comes out to be 113.04. We always need our units, and because it's area, it needs to be squared. So the area of a circle with a radius of 6 or a diameter of 12 is 113.04 centimeters. So we're done with today's lesson. You can head on to the practice for section 4.5, and if you have any questions, just come to class and let me know.